possible because we have cloud. That's why we invited you, Vasco, to come on board. Vasco is the head of public cloud of Claranet, another one of our sponsors. And you are an enabler of all of this fantasy, right? Not reality, I meant.
Thank you.
Thank you very much, Vasco.
Good presentation. (1972). This is the darkest moment of the commercial air transportation year in all of the air transportation industry. This year alone, more than 2,300 people have died. And this was not a unique event. You can see the trend all over the years. And you can see that if nothing has been done, this will continue to rise. And it was impossible to travel by airplane as we use it today. So the industry came together and they have done three things. One of them, it was failure propagation. What this means is that the aircraft manufacturers needed to understand on its development stage the impact of each part of the plane fails and how that would propagate to the rest of the airplane and that could cause an accident. And by understanding that, they will act upon that and create quality checks to make sure that all of the components that the plane has are safe. The second is crew communication. So a few years ago, beginning of the 80s, all the decisions that were made in the plane were made by the captain. And they understood that by communicating with the co-pilot and taking decisions together, they were able to reduce substantially the number of errors. And the third thing, and probably the most important, is continuous airworthiness. What this means is that everyone involved in the aircraft industry needed to come together to monitor the airplane at all times to detect issues that could cause serious impacts and have them fixed quickly. And you can see that the trend started to go the opposite way. To put this into perspective, everyone knows that traveling by plane is the safest way of travel today. But let me share you some odds. So you can die for a car accident, so your odd is 1 in 5,000. For being struck by a lightning, it's 1 in 100,000. For airplane crash, it's less than 1 in 1 million. Okay, so we can say that it's really safe to travel by plane. But, and this is possible because the industry is very rigorous in the way they take safety. So they take safety very, very seriously. And so every 4 years, the airplane stops to do a big maintenance. This usually takes between 10 to 15 days. It takes so long because every part of the plane is analyzed carefully. But this is not the only moment where the airplane stops for maintenance. Sometimes there are unexpected problems that occur, and this is called in the airline industry an AOG. An AOG means aircraft on the ground because something really serious happened and the aircraft needs to be, the problem needs to be solved. An AOG can cost more than 1 million euros per day. So you can see that this is a big problem for most of the airlines. To prevent AOGs, you can do several things. The first one, well, it's not really prevent. You can continue to have a reactive approach, which means that if you expect, you only replace a component of the plane after the failure. Of course, this will not prevent an AOG. You can try to have a proactive approach, and this means that you can try to replace parts of the plane before they break. But if you don't know which parts you need to replace, you could actually be replacing parts that are quite good, and they can break much more longer than you expect, and maybe you are just replacing too early. So the other way you can do this, it's by doing predictive maintenance. What this means is that you are continuously monitoring every component of the plane, and you can understand when is the best time to replace that part. Okay? So I'm going to talk to you about Embraer. So Embraer started to do predictive maintenance a few years ago, in 2004, when they launched the first family of the E-jets. And at that time, what they did, it's when the plane landed in the airport, an engineer go with a pen drive to the plane, downloaded the data, then connected that data to a computer, uploaded that data to an Embraer server. An engineer on Embraer downloaded the data, copied it to a drive, and put it in an archive, where only 2 or 3 people have access to it, because we are talking about sensitive data. And every time an engineer on Embraer wanted to do an analysis on that data, he needed to go pick the key, go to the room, pick up the disk, connect to the computer, decode the information, because we are talking about unstructured data that needs to be transformed into structure and need to be clean, you know. And then it can start with its analysis, which at that time was done by Excel. And if you needed to add different parameters that you wanted to analyze, you need to do that process again of decoding the information every time again. And if you wanted to compare the data from one flight with others, you actually need to pick another drive from a different flight and do that process again. So for the engineers to get into some conclusions, they usually take between 2 to 3 weeks to get an insight. So you can see some challenges in here. The first one is a lot of manual work. The second one, for each analysis, you need to go for the decode process once and once again. The third one is that you cannot share. It's very difficult to share information and share visual boards with other engineers, and they all can brainstorm around it and make decisions. The fourth is that when the data is increasing, it's getting more difficult to do this, because you don't have compute capacity to analyze that amount of data. And the last one, and one important as well, is that you cannot apply advanced machine learning techniques on it. And this is actually going to get worse, because the next family of E-jets E2, it's going to generate 2,000 more times the data than the previous family has generated. And what this means is that the data lake in Embraer next year will be more than the double than all the information that Embraer collected so far. And this will continue to grow. In the next 4 years, it will be almost 6 times what it is today. This is where Embraer called Claranet and AWS, so we partnered together to create Icon. So what we wanted to achieve with Icon is a way for the plane to communicate in real time using satellites with Embraer, and communicate some parts of the sensors, because we are talking about satellite communications, and they are very expensive. And the plane itself needed to have some processing capacity to do in-flight route optimization. The other part is when the plane lands, it needs to upload the data, transform that data in unstructured into structured data, ready to be analyzed by Embraer, and this needed to be done in a fully automated way, not like the process I showed you previously. So, and they also said, Embraer is a global company, so the airplanes are traveling the world everywhere. So they can land in Philippines, in Portugal, in USA. So they need to quickly upload the data into some place. The data needs to be secure. We are talking about very sensitive data. And the platform needs to scale, because as you can see, the amounts of data are going to increase. So the platform needs to be very robust and be able to scale. So we thought, okay, easy peasy. Let's put it on AWS. AWS is global. It's secure, and it can scale. We just put a bunch of servers and storage in the air. We You design your software to take this big data platform, and here you go. And if you need to scale, we can put more infrastructure. And if you need to scale again, we deliver more infrastructure to you. Everything was OK with our plan. But this is actually very hard to manage at scale. Imagine managing thousands and thousands of servers and terabytes or even petabytes of storage. And of course, the cost of this was actually going to be insane, so it completely killed the business case. So our team of architects and AWS went back to the drawing board and say, well, there's got to be a better way to achieve this. So we thought on architecture based on events. What this means is that you don't have any component of the infrastructure running if you don't need it. So we created this serverless architecture. In this serverless architecture, you don't have one unique server running. All right? So this is a very complex architecture, so I'm going to provide you a high-level analysis to show how this works. When the plane lands, it immediately starts to communicate the information and uploads that data into the cloud. This process takes about 7 minutes. And we are talking between 400 to 500 megabytes per flight. Then we see, and actually this is stored in S3 storage, which is one of the cheapest storage in the cloud. And then, as the S3 storage understands that there's a new archive or a bunch of archives there, it immediately starts an event. Remember, I told you this is an event-driven architecture, and talks to Lambda, which is a program that we write that says, do this, which picks up the data, the unstructured data, and breaks down that file into several files, smaller files. Why do we do this? Because on the next stage, we need to decode that information. We need to parse and translate that information from unstructured to structured data. And by breaking down in smaller files, we can parallelize work and complete this much more faster. So instead of analyzing a file with 400 megabytes that could take, let's say, 4 minutes, we can analyze 4 files with 100 megabytes each and complete the job in 1 minute. Then, another event is generated, and by using a different Lambda function, we go for a quality check on the data, once again, and aggregate the data into one file again. And before, actually, when the data comes into AWS Cloud and it's ready to go into this stage, the process takes about 5 minutes. And then the data is ready to be processed by a solution that we call EMR. And it goes to the data lake where it's ready to be analyzed by Embraer data scientists. Everything in this process is fully automated, no manual intervention. So you can see that it's easier now to do the process. No manual intervention. The engineer doesn't need to go with the pen drive to the plane. He's connected. He can use his Wi-Fi or cellular network to communicate the data to the cloud. It's scalable because if you have 1 terabyte of data, we launch several processes. If we have 1 petabyte, we can multiply that by 10, and you complete then the job in exactly the same time. So it's scalable and elastic. And since you don't actually have servers running, this platform has like extremely low cost of operating. You basically pay for storage and for the processing time of the EMR. This was able to save or to increase the productivity of Embraer team in 96%. So an analysis that they complete in 2 weeks, they will do it now in 4 hours. And they actually had a use case that proved that. A few weeks ago, they detected a fuel spillage in one of the flights. And they thought, was this an isolated event? Was this happening in other flights? Let's look into Icon and say that what he has to say. So they analyzed 3,000 flights more or less, which meant about 4 terabytes of data. And in less than 4 hours, they found exactly what caused the problem. It was when the airplane was on a descent route and with turbulence. When these two things happen, this caused the fuel spillage. And since they understand so well the problem, they also find several solutions for that. They could just replace a valve, change the software, but actually the better solution for this was just widening up the hole that returns the fuel from the end of the wing to the root. So they, in 4 hours, they understand the problem, and now they are recalling the planes to do this correction. So, and we are just scratching the surface. You can apply predictive analytics on everything. It's not just on maintenance, it's just not on manufacturing, on the air transportation industry. You can apply it in healthcare, in finance, you name it. But before implementing a big data platform, more than thinking, are we going to do a traditional infrastructure with servers and storage, or are we going serverless like we did? The first thing that you need to do is think about how are you going to make sure that you can trust your data. This is the most important part of a big data platform. It's not the infrastructure beneath it. It's the quality of the data. If you don't do this, you don't even need to bother on starting implementing infrastructure. Forget it. You will be wasting money because you will end up with data that you cannot trust, and this will lead you to a lot of bad results. Thank you.
Vasco. So Vasco just fooled us all right now because cloud, planes. It's all very simple up there, buddy.